Hello students, I am Dr. Parin Sheikh from LG Institutes of Applied Sciences. This is my fifth video lecture on group symmetry. In this video lecture, we are going to discuss about improper rotational axis in detail with the help of ethane molecule. So let's start the video lecture. In last video lecture, we learned about point group of the molecule. In this video lecture, we will discuss about improper rotational axis in detail by taking an example of ethane molecule. First, improper axis of rotation. As we know that improper rotational axis means rotation followed by reflection through mirror plane perpendicular to rotational axis. Sn is equal to Cn into sigma h. If Cn exists and sigma h exists, Sn must exist. However, Sn can exist if Cn and sigma h do not. The element Sn generates operations such as Sn, Sn2, Sn3 respectively. However, the set of operations generated are different depending if n is even or odd. Improper rotational axis where n is equal to odd. So, the operations are Sn raised to 2n is equal to identity. Sn raised to n is equal to sigma h. It can be understood by the taking example of eclipsed ethane where the value of n is odd. If the value of n is even, so the operation for the improper rotational axis Sn raised to n is equal to identity Sn raised to n by 2, which leads to center of inversion, and the example is of staggered ethane. Now this can be understood by the taking example of eclipsed ethane first. Eclipsed ethane having S3 improper rotational axis. That means S3 is equal to C3 into sigma h. Here are some key points. Two successive operation of plane of symmetry which leads to identity. And second, C3 raised to 3 is equal to E. That means Cn raised to n is equal to E. Now here we will go for S31. That means C31 into sigma h. This is one unique operation for the improper rotational axis. Next, S32. Here 2 times improper operations which leads to C31 into C31. That means C32 and 2 times sigma h which leads to identity. So this is not unique operation and it becomes C32. Next, S33. That means 3 successive operation of improper rotational axis which leads to sigma h. As we know that C3 raised to 3 is equal to identity. S3 4 times means 4 successive operation of improper rotational axis which leads to C31. Here C3 3 times into C3 1 time and 4 times sigma h which leads to identity. Next, that is S3 5 times successive operation of improper rotational axis which leads to S32 into sigma h. That means this is one unique operation. Next, S36. That means 6 times applying improper rotational axis operation which leads to identity. From this, we can say that only 2 improper operations S31 and S35 which are unique because which leads to rotation than reflection. This can explain by giving operation to eclipsed ethane molecule. Point group of eclipsed ethane, that is D3H. Here S31 is equal to C31 into sigma H. Now how we can operate this? First, this is structure of eclipsed ethane molecule. First we will apply C31. Here we have applied C31 anti-clockwise. So this is the orientation that we obtain. Next we will apply sigma H. By applying sigma H, the front carbon becomes rear carbon and rear carbon becomes front carbon. This is the orientation after applying reflection or sigma H. S3 is equal to C3 into sigma H. Now this is the eclipsed ethane molecule. By applying first S31, we get this orientation. Now successive second improper rotational axis operation which leads to molecule this, and third time improper rotational axis we will get this orientation. Here compare this orientation with the first one. Here the difference of only sigma H, that means S33 which leads to sigma H. Next, that is S34, 4 times improper rotational axis which leads the molecule this orientation. Next we will apply S35. So here we will get this orientation. And the last S36 which leads to identity. Here we get the original orientation back. This is about eclipsed ethane. Now the conclusion. We have 6 different improper rotational axes in which equivalent operations are there. Only S3 and S35 and S31 which leads to 2 unique operations. Next, where n is equal to even. Here we are taking example of staggered ethane. In case of staggered ethane, S6 is equal to C6 into sigma H. Some key points. 2 times sigma H which leads to identity, and second, S6 raised to 6 is equal to E. That means Sn raised to n is equal to identity. Here we will apply successive operation to staggered ethane. S61 is equal to C61 into sigma H. This is unique operation. S62 means 2 successive improper rotation which leads to C31. Okay. S63 which leads to center of inversion I. S64 which leads to C64 is equal to C32. Here there is no C3 symmetry element present in the staggered ethane. S65 which leads to S65 into sigma H. It is unique operation. S66 which leads to identity. Here S61 and S65. These are 2 unique operations that we get. The point group of staggered ethane is D3D. S61 is equal to first C61 into sigma H that we will apply to ethane molecule. This is the orientation for the staggered ethane molecule. first we will rotate it by C6 rotational axis. Here anti-clockwise rotation is given. Next we will apply sigma H. Here also front carbon becomes rear and rear carbon becomes front, and we get this orientation. Now this we will apply to successive improper rotational axis to the ethane, to the staggered ethane molecule. S6 is equal to C6 into sigma H. S61 which leads the second orientation. Successive S62 which leads this orientation. Next S63 which is identity. Now here we can compare this molecule, this orientation with the first orientation. Here we get identity operation. Next S64 which leads to this orientation. Next we will apply S65 which leads this orientation, and next we will apply S66, that means we will get the original orientation back, means which leads to identity. From this we can say that as an operation and equivalent operation. Here only improper rotations add only two unique operations. This is about staggered and eclipsed ethane having improper rotational axis. Okay, thank you.